Hey everybody, I just thought today we could do some calculus review. These questions are word for word verbatim from my Calculus 1 final I took at university. So hopefully you'll learn something new, or this could be a good review for your calculus final you're about to take. Alright, so this first question was to find the limit as x approaches infinity for this function. Alright, so the first thing I would do is I would rewrite the numerator in order from greatest to least power. So I would rewrite this as minus 3x plus the cubed root of x minus 5 all over 5x plus here, and I'll match the syntax as the numerator, cubed root of x squared plus 2. So this question gives us a hint as to what to do in it. It says divide the numerator and denominator by the highest power of x to find the limit. So what is that and why can we do that? So the highest power of x in this case is here. Let's write down all the powers of x. Here, this power of x is 1. This power of x is 1/3. This power of x is 2/3. This power of x is 0, and this power of x is 0. Alright, well, let's look at those on a graph. That can help explain why we can neglect some things. So x to the 1, or just y equals x, that's just this linear line, as I'm sure you all know. Okay, x to the 1/3 and x to the 2/3, well, those are, let's just look at the square root of x. That's a graph we're all very familiar with. So y equals the square root of x. Here we'll say that this is 1 and this is 1, so it will cross here, and so this will look something like this. Alright, not picture perfect, but you understand what we're trying to get across. And then x to the 0, well, that's just 0, so that's just like any horizontal line. It can be anywhere. So here, it doesn't have a slope. It's not a value, really. So what I want you to see is that our first line, our y equals x line, is approaching infinity a lot faster than our y equals x squared graph. And because this will reach infinity faster than this one, our square root of x is negligible when compared to x. That is why this part of our equation can just be canceled out. And once we cancel out this part of the equation, we'll be left with negative 3x over 5x. Now we can cancel again our x's, as they're the same thing, and we're left with negative 3/5. So negative 3/5 is the limit to this problem. Alright, let's go to our next problem. Number 3, we started with number 2. Find the limit if it exists. Alrighty. So what is this problem testing us on? It wants us to find limit, and okay, what I'm seeing is all of these terms have an x in it. So I want to talk about this for a minute because I see lots of students make this mistake. They see that all these terms have an x in it, so they go ahead and they cancel the x out. They'll mark it out and they'll simplify. And they'll simplify and have x squared plus 12x minus 5 all over 5. Okay, but we can't technically do this. It is implied that our domain is everything. Our domain is implied to be from negative infinity all the way to infinity. And whenever we divide by x, we are saying that x cannot equal 0. Because if x equals 0, then we'll have an undefined function. Therefore, we can't just willy-nilly cancel this out. Okay, so what can we do? How do we get around this issue? How do we solve this problem the accurate way? So the answer to that is the wonderful L'Hopital's rule. And if you're in calculus, you have heard this. And if you're watching this video because you just got into calculus or you're just wanting to do some basic calculus, this will come up. L'Hopital's rule is fantastic. It helps us get around limits that we normally wouldn't be able to solve. And what L'Hopital's rule basically says, it says if we have a limit and as x approaches anything, and we have some g or f of x over some g of x, whatever this limit equals to, whatever it equals to, is going to be the same thing as the limit for the derivatives. So for f, the derivative of f of x and the derivative of the g of x. To use L'Hopital's rule, first, the limit you're working with, your f of x over your g of x, needs to either be 0 over 0. So normally whenever we plug in our c for our function, whatever, if we were to get 0 over 0 or infinity over infinity or negative infinity over negative infinity, we can use L'Hopital's rule in these situations. And this is one of those situations. You can see you plug in 0, you're going to get 0 over 0. It will be this case, and we need to solve. So let's go ahead. Let's use L'Hopital's rule. Let's solve this problem. So what is the derivative of the top? Well, we'll get 3x squared plus 24x minus 5 all over 5. Remember, our limit is as x approaches 0. And we plug in 0 for this case, and we'll be left with negative 5 over 5. So our limit for this problem is negative 1. All right, perfect. So there's a quick L'Hopital's rule problem. Let's go to our next problem. The inequality, as follows, holds when x is measured in radians and the absolute value of x is less than 1. Find the limit if it exists. Alright, so this x approaches 0, sine of 0 is 0 over 0. So we could use L'Hopital's rule again. We could use L'Hopital's rule. And you are more than welcome to. But there's a reason this inequality was given to us. This problem wants us to use something other than L'Hopital's rule. So what can we use? Well, this inequality is a huge hint. We're going to be using the Squeeze Theorem. The Squeeze Theorem, sometimes it's the Pincher Theorem, sometimes it's sandwich. It has lots of names. Sandwich principle, Squeeze Theorem, Squeeze principle, Pincher, whatever. Anything that involves compressing the two sides. And that's exactly what this is. The Squeeze Theorem or sandwich or whatever, all it says is that you have some function f of x that is less than or equal to our some function of g of x, which is some less than or equal to some function h of x. If you have this scenario and then our limit for our f of x equals the limit of our h of x, which is some value L, well, if these are the same and f of x is less than g of x, which is less than h of x, well, then our limit for our g of x must also be this same L. And so this comes in great handy whenever solving something like this. Something we might not normally know how to solve is now solvable. And so if we look at this, we need to solve the limit for our lower bound and our upper bound. Our upper bound is already set. It's already 1. So the limit as x approaches anything for 1 is just going to be 1. So we just need to check that our lower bound is also 1. So let's get some room here. Let's check our lower bound. Let's see what it will be. So let's change our color. Here I like this dark blue. So the limit as x approaches 0 for our lower bound, 1 minus x squared over 2. Let's plug in 0. What do we get? We get 1 minus 0 over 2, which is just 1. Therefore, the limit of our lower, so the limit of our f of x equals the limit of our h of x, so the limit of our g of x, in other words, our sine of x over x, must equal 1. So this limit equals 1. Alright, let's go to our next problem. Find the vertical asymptotes of the given function. Alright, so how do you find vertical asymptotes? What is vertical asymptotes? Okay, if I'm thinking about vertical asymptotes, the first thing that comes to my mind is the graph of 1 over x. And this is a very standard graph and very popular graph. Looks something like this. So the vertical asymptote in this function is our y-axis. Okay, and what is our y-axis? Our y-axis is whenever x equals 0. So what does x equals 0 mean for our function? Well, our function is 1 over x, so if I plug in 0 for x, I'll get 1 over 0. And what is this? Well, this is undefined. This is undefined because you cannot divide by 0. So anytime our denominator equals 0, we will have a vertical asymptote. And so that's what we need to do for the problem. Let's set our denominator equal to 0 and solve. So what is our denominator? We have x squared plus 2x minus 35. And we need to set this equal to 0. Here, let's just factor this. Okay, so we have an x and x. This is a plus and a minus, so we'll have a plus and a minus. 35, 7 and 5. 7 is greater than 5, so it'll be over here. And so our x is going to equal -7 or 5. So these are our vertical asymptotes. All right, perfect. File, open recent. Okay, let's go to our next problem. Find the derivative of y equals 10 over x plus 5 secant x. Alright, so we need to know how to find basic derivatives and trigonometric derivatives. Alright, so let's do the left side of our function first, this 10 over x. So if we just have our function and equals 10 over x, and we want to find our derivative, well, the first thing I would do is I would change 10 over x to 10 times x to the minus 1. It's just easier for me to think about the derivative in this way. So if we take the derivative of this, what do? Well, we just use the power rule for derivatives, so we'll multiply the -1 down. So we'll have -1 times 10, and we'll have -10 times x to the minus 2. And I'm going to then change this back into the same form as it was used in our problem, the 10 over x. This can be written as -10 over x squared. Alright, now let's look at our secant function. So we'll say g of x is our 5 secant x. So we're just going to focus on secant because the 5 will just be there. So what is secant? Well, secant is what? Secant is what? Secant is 1 over cosine. So if you don't know the derivative of secant off the top of your head, that's fine. We can change secant to 1 over cosine, and then let's use the quotient rule. So let's refresh our brain. What is the quotient rule? The quotient rule is how you can find a derivative for something that is being divided by something else. So the quotient rule is whenever we have the derivative of our numerator times our denominator minus our numerator times the derivative of our denominator all over our denominator squared. So let's change back into this beautiful blue and find the derivative for secant. Okay, so secant is 1 over cosine, so we're looking for our derivative. What is it going to be? Well, the derivative of our first, the derivative of our numerator is 0 times our denominator, so times cosine, minus our numerator, which is 1, times the derivative of our denominator. The derivative of cosine is negative sine. And this is all over our denominator squared. So this is all over cosine squared. So let's simplify this, make it pretty. 0 times cosine is, of course, 0. Minus 1 times minus sine is going to be positive sine over cosine squared. And what is this? Well, this can be written as what? 1 over cosine times sine over cosine, leaving us with secant x tan x. So the derivative of our secant is secant x tan x. So whenever we put all of this together, we will have minus 10 over x squared plus our 5 secant x tan x. So this is the final answer. This is our y prime. All right, great job. Let's do another problem. File, open recent. Let's do one more. All right. Does the graph of the function y equal tan x minus x have any horizontal tangents in the interval 0 to 2 pi? X has to be between 0 and 2 pi. All right, so one rotation for trigonometric functions. So let's figure this out. So what is a horizontal tangent? Okay, well, let's draw a graph. A horizontal tangent is, well, something horizontal will be parallel to the x-axis. Okay, so let's look at this simple parabola. We'll say that this is y equals x squared. Okay, so what would the horizontal tangent be? The horizontal tangent would be right here, right at the origin. It will be parallel with the x-axis. And more importantly, if you realize the slope for anything horizontal is 0. So we want our slope to be 0. Well, how do we know if our slope is 0? Well, by finding the derivative. The derivative of a function gives us the function for the slopes of our original function. Just said function a lot there, but hope you followed. So what we need to do to solve this problem is to find the derivative of tan x minus x, set it equal to 0, and that will tell us our horizontal tangents. So let's go do that. So we already know that the derivative of minus x is going to be minus 1. But what is the derivative of tangent? And I'm outside, so if you hear a plane flying over, I'm sorry. But the derivative of tangent, if you don't know already, that's fine. We'll figure it out. So tangent is what? It's sine over cosine. And I hope you can follow my shorthand here. I know I'm not writing tangent of x every time, or even the full word for sine of cosine, but know if I write s or c, I really mean sine of x over cosine of x. Sometimes it's just a little bit too much writing, but if you don't follow, leave a comment and I promise I'll start doing it. So, well, what is sine over cosine? Well, luckily we just had a problem dealing with secant. So secant was 1 over cosine, and we'll have 1 over cosine times sine. So this is just secant times sine. So to find the derivative for tangent, we can use the product rule. So what was the product rule? I just wrote down the quotient rule, but the product rule is a little bit different. It's actually quite a bit simpler. So the product rule is just the derivative of the first times the second plus the first times the derivative of the second. So this will be our first term and this will be our second term. So let's go here, let's go to this hot pink. Give us some room. All right. So we're finding the product rule. So for tangent, the derivative of tangent. So first we have the derivative of secant, and we figured it out in our last video. I'm blanking right now, but the derivative of secant was secant tangent. All right, so the derivative of secant in our last problem, secant times tangent times g, which is just sine, times sine, plus our first, which is secant, times the derivative of our second. The derivative of sine is cosine. So let's simplify this down. Secant is 1 over cosine times tangent, sine over cosine, times sine, plus secant times cosine. Secant is 1 over cosine times cosine. So this right side of our equation, 1 over cosine times cosine over 1, this will simplify down to 1, so plus 1. And this left side of our equation, we have, if we rewrite, we have 1 over cosine times sine over 1, so that's just sine over cosine times sine over cosine. And so this equals what? This equals tangent squared plus 1. So the derivative of tangent is tangent squared plus 1. So the derivative for our whole y, here, let's give us some room. Give us some room, all right. Our derivative for our y equals tangent squared of x plus 1 and then minus 1. So this simplifies down even more to just tangent squared x. Alright, so to answer the final part of the question, we need to set this equal to 0 and solve. So when does tangent squared equal 0? Well, what is tangent squared? Well, again, tangent squared is just going to be sine squared over cosine squared. So when does this equal 0? Well, this equals 0 whenever sine equals 0, or whenever sine squared equals 0. And this equals 0 whenever sine equals 0. So when does sine equal 0? Well, sine equals 0 at 0 and at pi, and at 2 pi, and at 3 pi, and at 4 pi, etc., etc., etc. But it's just asking for between 0 and 2 pi. So the answer will be sine of x equals 0 whenever x equals 0, pi, and 2 pi. So this is the final answer to this problem. Alright guys, we'll finish up the rest of this test in the next video. Thanks for following along. See you next time.